Hey there, I'm Carl Tashian, and I'm a developer advocate at Smallstep. And today we're going to do a weekend project, DIY single sign-on for SSH. And if you want all the details of exactly how to go through this, because there's a lot of steps, we've also written a blog post that has a step-by-step walkthrough and some scripts that you're going to need in order to get this set up for yourself. So before we start, I want to show you how things will look and feel once we have single sign-on for SSH all set up. I've got two EC2 instances here. One of them is a Certificate Authority that issues SSH certificates for my users and hosts. And the other one is a target host. And this host has already gotten a certificate from the CA. So I'm just going to SSH into this target host. And opens up the OAuth flow for Google. And then when I go back to the command line, I'm signed into the host. So how did this happen? So the Google OAuth OIDC flow gives us back a identity token. And that identity token is signed by Google's private key, and it has my email address and username in it. So we take that token and we pass it off to the CA. And the CA accepts the token, is configured to accept it and exchange it for a user certificate. And we can even see that user certificate in our SSH agent. And we can parse it. Take a look at it. You can see that it's got, so it's valid for 16 hours. And it has my name and my email address, my username and my email address as principals. And that's what we're going to set up today. The other piece of this that's really important is we are using a proxy command in the SSH configuration on this machine. You can see this proxy command is the wedge that allows us to do Google single sign-on, and it puts it ahead of the SSH handshake, so that by the time this magic command finishes running, we have an SSH certificate in our agent that the target host will accept. So that's the basic setup for single sign-on for SSH that we're going to build today. All right, so let's get started. I'm inside a brand new Google Cloud Platform project, and I'm going to set up the OAuth consent screen. And I'm going to configure it for an internal application. And I have to give it a name, so I'm going to call it SSH. Save that. And then I want to make a OAuth credential. So I'm going to go in credentials, create credential, and I'll create an OAuth client ID. Just going to use other. And then I get my client ID and my client secret. And we're going to plug those into a script in just a second. So let's just stay right there. So over here, I have a script that we will use to set up the EC2 instance. So it's just an initialization script for the certificate authority. And I'm just going to go through it line by line so that you can see how it works. So we'll grab the script, and I'm also going to modify it because we need to fill in some variables at the top here. So this takes in the OAuth variables that we just set up. So let's get those credentials. The client ID. And the client secret. And then we also need the domain name that people are going to use. And this is just my family domain name. This has to be the same as the organization name of the Google Cloud project. So because they have to be aligned. And then I'm just going to give it a name, Carl CA. This is the name of my certificate authority. And a password. for my root key, which should be really strong. And I'm going to put my email address in here. All right, so I'll show you what the rest of the script does. So this is the discovery endpoint for OpenID that the Certificate Authority will use to get Google's public key and things like that. It's a configuration endpoint. We're going to download these two Debian packages. This is the CA itself, the Step Certificates project, and then Step CLI is a command line tool that we use to set up the CA, and we also are going to use it locally to talk to the CA. And then we need to set up our path and put the password that we've set into a text file that the CA will read when it starts up in order to unlock the keys. And we're just going to set up a little, this is a service definition for system D. We want to set up a service, and this just runs the CA, right? Keeps it running. And it's using the CA's configuration file, and then it pulls in our password. So it's pretty straightforward. And we're going to make that config file here in a second. So we need some variables from the instance metadata API. So we're pulling down the host name and IP, and we're getting the account ID for our AWS account from the instance identity document. And this is where we use all that stuff. We're going to initialize the CA. This creates the ca.json file and generates all the basic root keys for the CA. And we're setting up an SSH CA. And we're going to, here's our password file. So that'll set the passwords for all the certificates. And then we're going to add provisioners to the CA. Now, provisioners are really just like methods that the CA will allow clients to use to get certificates issued to them. And the first sort of provisioner we're going to set up is a Google OIDC provisioner. And this is where we use the Google OIDC variables that we set up, and also this allowed domain, right? So this is just going to say, this will configure the CA to accept the OpenID, the OIDC identity token in exchange, and it will exchange it for an SSH user certificate, right? And so when it gets an OIDC identity token, it makes sure that it's signed by Google, the public key that's at the configuration endpoint for Google, and validates that token. And then it also makes sure that the domain of the user that has, that's identified by the token is matching with our allowed domain. So I can't just issue SSH certificates for anybody in any domain, right? And then we're going to add another provisioner for Amazon Web Services. Now this provisioner this is how hosts are going to get their host certificates. And this provisioner actually constrains so it uses the instance identity document as the proof that the host is who they say they are. And it's constraining by the AWS account ID. So I put the AWS account ID in here so that only hosts within my account can can get a SSH host certificate from the CA. And that instance identity document is signed by Amazon. So it's sort of similar to the Google one where the CA is going to validate the instance token against, it's going to validate that it's signed by Amazon's public key. And then we're going to add one more provisioner, which is just called SSH pop. And this provisioner will renew host certificates that have not yet expired. So on our host, we will have a little cron job that runs like once a week, and it is going to renew that. It's going to use this provisioner to renew. So it'll send its its certificate to the CA, and the CA will give back a new certificate with a further expiration date on it. And that's what that provisioner does. And then finally, we're going to just change. So there's a template that the CA creates. And this is how it configures our local client when we finally get to that step where we're setting up our local machine. Any end user, there's templates for the SSH config that our end users will have. And this one, we're just tweaking that template so that it's going to default to the Google provisioner for our end users for single sign-on, rather than trying to prompt them whether they want to like use the AWS provisioner on their local machine. So that's just makes just like streamlining things. And we're going to start the CA and make sure that it's in the that the path is in the root user's profile. So now we can set up an EC2 instance, and we'll run this script as a user data script, as a launch script on that instance. Before we do that, we actually need to get our VPC set up properly. I've just got like a basic VPC here. I've added an internet gateway to it, and I need a couple of security groups in my VPC so that I can have access for SSH and for HTTPS in the case of the CA. So I'm just going to create a couple of security groups. And for this one, I want to make sure I have an inbound rule that allows SSH from anywhere. And for my other security group, I want to do HTTPS. This is going to allow hosts to connect to the CA. And in my case, I also want HTTPS to be available anywhere. So I'm going to set an inbound rule to allow HTTPS from anywhere. That way my users and my hosts will be able to get to the CA. So that should be it for our VPC. Now I'm going to go into EC2 and I'm going to launch an instance for our CA inside of that VPC. So I'm launching an instance. I'm going to choose the Ubuntu 18.04 AMI, and I want a small instance. And then on the step 3, I'm going to just put in my script that I just created. And yes, I'm just gonna use this script to launch my CA. And I want to make sure that it is in the HTTPS and SSH security groups. I've got my PEM key already, so I'm just going to launch that and wait for it to spin up. All right, so now the instance is up and running. I'm just going to give it a name, CA. And we'll get the public DNS so we can log into it. Check it out. All right. So we're just going to check the logs. First, we can see that the CA is running. And it looks like it is. And then we'll check out the logs from the initialization. Yeah, so it looks like it created a whole bunch of keys and certificates. And I don't see any error messages or anything. Seems like it put everything together. The only thing we really need off of the CA is the root certificate fingerprint. So under step CA certs, there is a rootca.crt. And I'm just going to get the fingerprint off of this root CA certificate. This is what will allow us to bootstrap our new hosts and also new users. And they'll be able to talk to the CA using mutual TLS because they have this fingerprint and the URL for the CA. So this is really the only bit of information we need off of this machine. I'm just going to put it into a file here. I'm going to say CA fingerprint is this. And I'm also going to make the CA URL. I'm just going to make a variable for that because it's this host name. And actually, it needs to be HTTPS. Great. So the next step is to run, we're going to launch another EC2 instance. This time we want to actually bootstrap a new host so that it gets a host certificate on our CA. I actually feel like it would be useful to do this one manually instead of using a launch script. So I have a script, but we're just going to run through it as we set up this server. So I'm just going to launch the server without any like user data script. And I'm going to put it into the SSH security group. Just going to wait for that to spin up. All right, so we have our second host up and running now. And we can SSH into that one. And let's just become root here. And now we're going to set this up with a host certificate and have it bootstrap to the CA. So this is the script that does that. But I'm actually just going to like copy and paste from it as we go. So first of all, I need my fingerprint that I got from the CA. And I need the CA URL. So let's see. So I just need these two. And I'm going to download the step command line tool. Install that Debian package. Great. And then I'm going to bootstrap this host with the CA. So that just downloaded the root certificate for the CA and set up a little config file for the step tool. And the next thing I want to do is get this. This is the host. This is the SSH user key that the host is going to use to validate user certificates. So if I just run this by itself, you can see this is downloaded from the CA. And we're going to save this so that we can set it up in our SSHD configuration as a trusted CA key. And then we're going to go to the instance metadata API and get a couple of bits of information, local host name. We're going to get this token that this is the step tool generating a token from the AWS instance identity document, and it's a JWT that has the instance identity document inside of it that'll be used as essentially like a certificate request to our CA, and the CA is going to give us back a host certificate in exchange for this token. So it's a one-time use token, and in fact we can look at this token and see the contents of the JWT. And inside of here, you can see the encoded instance identity document and the instance identity signature. In fact, we can even inspect the document itself if we just decode that with base64. Oh, except I don't have JQ. Oh well. So the next step is to go up to the CA and get a certificate. So we've got all the environment variables in there. I just ran that next command. and it looks like it got a certificate for us. We can even take a look at that certificate. Oh, that is the wrong file. So this is the host certificate, and you can see that it has listed as principals the host names for this host. And it's valid for a month. Now we just need to change the SSHD configuration so that it will trust our, so it'll use our host certificate and so that it'll trust our CA. So that just appended to the SSHD configuration. Let's just take a look at the SSHD config that we got. Oops. So we are going to trust anyone who presents a user certificate that's been signed with the SSH user certificate key. And we are going to use this host key and host certificate that we've just gotten from the CA. So now that we've done that, we just need to restart SSH. And there's one more step to setting up this host, which is we want to set up a weekly cron task to rotate our CA certificate. So I just am putting this into a cron file here and making sure that it has the right permissions. And that should just run automatically weekly. We can even run the command that it uses if I just make sure I've got the right step path. Oh, I don't actually have that. Oh, yeah. Well, I'm already logged in as root, so I should be fine. And if I just run this, it will go to my CA, and it'll take the certificate that I just got, and it'll go and get another one that's using this SSH pop provisioner. It's going to get another one and replace the old one with an extended expiration date. So our host is bootstrapped now, and we have the CA. The last step is to be able to SSH into the host. And so before we do that, I need to actually create a user for myself on that host. So I'm going to go back in with the PEM key, and I'm just going to add a user for myself. And I'm just using the same username as in my email address that I'm going to use to sign in through OAuth, because that's what I'm going to get a certificate for. My certificate will be given to, it will have Carl listed as a principal in it. And in order to set up my local environment, so that's it for the host. On my local environment, I need this CA URL and fingerprint. And then I'm going to do the same bootstrapping locally that I did up on the host. So running this bootstrap command. And that just saves the root CA certificate. So now I can log in using Google and get myself a user certificate. So now we're going to go through the OAuth flow. If I go back to the command line, this has now added a certificate to my SSH agent. So you can see it here. And we can even run it through the step tool to inspect it. So you can see that it has Carl as a principal and also my email address as a principal. And it's valid for a month. I'm sorry, it's valid for 16 hours. The host certificate's valid for a month, but this one's valid for 16 hours because we want to be able to renew it each workday essentially. And the last step is we want to configure our SSH client locally. Now, this just added a couple of files. The SSH config, the only change there is that it includes this SSH config, the second one. So let's take a look at that. This SSH config has a match block in it that runs check host on the host name that we're connecting to. And this check host will go up to the CA, and it'll check to see that the CA has issued whether the CA has issued a certificate for this host. And in fact, you can do step SSH hosts to get a list of the hosts that the CA has issued certificates for. And if that host that we're trying to connect to is in the list, then this command will return a true value, and we will evaluate this block. And the critical piece of this block is the proxy command, which this is using the step tool to check to see if our user certificate is still valid. And if it's not valid, it's going to run us through the OAuth flow before it tries to do the SSH handshake. So it's just like a little wedge that goes in before the SSH handshake. And we can try it out now. Oh, there's one more thing I want to show you in here, though, which is the actual the known host file, which is simply has an entry that has the host certificate from our CA, and we're going to trust any host that offers that's a certificate signed by the host key. So this is our host CA key. And let's try it now. In fact, what I'm going to do is I'm going to remove my regular SSH known host file because I already added the fingerprint for the target host in that. And I'm just going to SSH directly to my instance. So this instance right here. And you can see that we're connected. There's no host fingerprint prompt. I'm signed in as Carl. And I can even do that with -VV, which will give me some verbose output. And we can see where the certificate exchange happens. So here's the certificates being offered and accepted by the host. So if you want to go through, we can go through the whole flow again at this point too. If I just remove the certificate from my agent, from my SSH agent, and then I try and SSH in again to that host, then it will pop open a browser. We'll go through our OAuth flow, and then we're connected to the host. So that's it. That's single sign-on SSH.